Hello, our beautiful students. Okay, we're going to finish out the 10.2 notes, and I have my coffee ready to go, and my pencil, and my calculator, and of course our perfect square list. Now, if you have a perfect square list on a computer, that's perfectly fine, but we will reference it as we go through the lesson. Now, what we're going to do is throw variables at you, variables like X, Y, Z, Q, M, N, O, not O, because O looks like zeros. Okay, so let's see what happens when we throw in variables. The rule is pretty simple. You can bring out like one group for every two that you have inside. So let's think about this. If you have x to the 10th inside, you can bring out x to the 5th. Now, maybe that makes sense to you. That's because you can bring out 1 for every 2 that you have. So you simply divide by 2. So if you have x to the 10th, there's 5 groups of 2. Now here's a visual. So if you have x to the 10th, like this, inside a square root, you can bring out groups of 2. So if I'm going to circle these in groups of 2. So watch this. Group of 2, group of 2, group of 2, group of 2, group of 2. When I did that, do you notice how I have 1, 2, 3, 4, 5 groups of 2? That means you can bring out x to the 5th power. Okay, so that tells me that you had 5 groups of 2 originally, and that made your x to the 10th. So the idea is to draw circles around every 2. Now, sometimes you are going to have some left inside. In this example, like when you do 5 divided by 10, you have nothing left over, right? Like if you do 10 divided by 5 or 10 divided by 2, it's a clean-cut answer. It's not like 10 divided by 2 is a clean-cut 5. There's no leftovers, there's no remainder. But sometimes you are going to have remainder. Like if you do 13 divided by 2, 13 divided by 2, there are 6 groups of 2, but then there's like a leftover as well, like a remainder. So you're going to bring out x to the 6th, but you're still going to have 1 x left inside. That's because there's 6 groups of 2, which is 12, and an extra 13 inside. Here's a visual. You ready? Let's circle groups of 2. By the way, there are 13 x's here. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 x's there, which is why I wrote x to the 13th. Now you ready? Let's circle groups of 2. 1 circle, 2 circle, 3 circle, 4 circle, 5, 6. Uh-oh, can't circle this little guy. He's kind of like a leftover. Okay, he doesn't really have a buddy, so he has to stay inside. So let's count our circles. 1, 2, 3, 4, 5, 6 circles. So we're going to have x to the 6th, because we had 6 groups of 2, and a leftover. He's trapped inside. He didn't like have a buddy to break free. They have to have a buddy to break free out of jail, and he didn't have one, so he's still in jail. All right, number 7. I thought that was an excellent way of explaining it. Thank you. Me too. It's good. You can agree with yourself when you're the only one here. All right, so number 7, you see that 21 on that negative? We're just going to bring him down. Boom, 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 boom. Oh, now we have to split 27 apart. Let's do that right here. Let's go ahead and fix that 27. So I had the square root of 27. I need to go to my list. What goes into 27? Let's try 16. It's a decimal. Let's try 9. Ooh, magic. 9 times 3. So instead of seeing a 27 as the square root of 27, please see it as the square root of 9 times the square root of 3. And we learned in our past lesson that that becomes the square root of 9 is 3, square root of 3 left over. Ooh. So I'm going to bring my 21 down, and then I'm going to bring down my 3, leave a space, as square root of 3. Now we need to talk about those x's. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of drew those funny, didn't I? Circle groups of 2. Ooh, see how I have 4 groups? 1, 2, 3, 4, 4 groups. That means I can put, I need just a little more space, land jelly. I need a little more space. I'm going to put x to the 4th here because I had 4 groups. Remember how I had that leftover square root of 3? Look, I also have, he's a leftover. This 3 is a leftover. So is he. He's also leftover. So he has to go in there with the 3. They didn't have any buddies to help break them out. The last step is to take this 21 and multiply it by that 3. So negative 21 times 3 is negative 63. So final answer, negative 63 from the 21 and the 3. X to the 4th, because those broke out of jail. X is left over. All right, let's try number 8. So bring down the 3. Now let's talk about the square root of 150 over here on the side. All right, here it is. What number goes into 150? Okay, you guys are going to see some magic buttons. 150 divided by 144, 150 divided by 121, 150 divided by 121, 150 divided by 100, 150 divided by 81, 150 divided by 64, 150 divided by 49. That's supposed to be 150. Decimal, 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 decimal. 36, decimal. Magic, it's 25 and 6. And we learned from previous lessons that the square root of 25 is 5, the 6 is trapped. Okay, so now I'm going to write a parenthesis here. Put my 5, I'm going to leave a better space than I did last time. Square root of 6. Okay, that looks like a really bad 6. Was anybody else thinking that? I know you guys are just thinking that you can't wait till I'm done, but I'm not done yet, so stick with me. Now let's deal with these letter B's. 1, 2, 3, 4, 5, 6, 7, 8. Circle groups of 2. Boink, 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 boink. Ooh, they all got circles. How many groups? 1, 2, 3, 4. 4 of them. So I'm going to have a B to the 4th from my 4 groups. Are there any leftovers? No way, Jose. So my final answer is 3 times 5 to make 15. B to the 4th. And that leftover square root of 6 that does not get to come out. Number 9, bring down the negative 2. And then we'll figure out what goes beside it. Okay, so we have to deal with the square root of 243 on the side. All right, you guys are about to see some magic happen with my perfect square root sheet. We're on 243, guys. 243 divided by 169. No, 243 divided by 144, 243 divided by 121, 243 divided by 100, 243 divided by 81. Ding, 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 ding. It is 81 and 3. So this is going to be 81 times a 3. And the square root of 81 is a 9. Square root of 3 left over. So watch where I'm going to put that. I'm going to put my 9 here. Leave a space. Square root of 3 here. Now let's deal with those variables y. 1, 2, 3. Circle groups of 2. Boink. 1 group of 2. So my 1 group of 2 goes here. Put a 1 if you want to indicate that was 1 group of 2. And this is my leftover. He has to stay trapped. He didn't get break free. So the 1 group went right there. And this leftover went right there. Okay. Last step, we're going to do negative 2 times 9. Negative 18. Bring down the y to the 1 power. Bring down the square root of 3 and the y, which are trapped inside. You don't need the 1 power, by the way. I just put it there for emphasis. All right, next. Ooh, look at this magic. We're going to have to bring down the outside. What's on the outside? A 7, right? Technically, a 1 times a 7. I know, 1 times 7 is 7. We have to put these together first, guys, before we try simplifying anything. So I need to do 5 times 15. So I get 75 inside of here. And then C1 and C2. So a C1 and a C2 makes a C3. With exponents, you add them. Wow, I really exaggerated that, didn't I? Did not need to be that big. All right, now it looks like the problem's up here because I put them together. You have to multiply them together before you start. Did you like that? Oh, it's like an alligator bite. Yes, I am 3 years old. Okay, bring down the 7. Let's deal with the square root of 75 over here on the side. You can get my handy dandy chart and my handy dandy calculator. 75 divided by 64. 75 divided by 49. 75 divided by 36. 75 divided by 25. Ding, 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 ding. That's a... Hold on, guys. I'm going to do 75 divided by 36. Not 5. 75 divided by 25. There it is. Ding, 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 ding. You divide by 25 on your list. You get a clean cut 3, an integer. So we're going to change this to, on the side, 25 times 3. Feel free to use a different piece of paper if this is too tight. The square root of 25 is 5. The square root of 3 hangs out. So put a 5 here, leave a space, square root of 3. Now let's take a look at these C's here. I have a total of 3 of them. So the question is, how many groups of 2 do I have? 1 group of 2. So here's my 1 group of 2. And here's my leftover 1. Final answer, 7 times 5 is 35. C to the first, and the trapped square root of 3C. Number 11, we need to put them together. So we're going to do this 2 times this 128. I'm going to use a calculator so I don't have to redo my notes. Good, we're still recording. And, ooh, I have this y, I have a y1 times a y5. Well, when you add those exponents like we learned in chapter 7, you get a y6. So in case you're wondering, like, where do those numbers come from? Or maybe you just have your audio off, which is not a good idea, but they're not hearing that that's not a good idea if their audio's off. I did 2 times 128. That's how I got 156. And I did y1 times y5. See, so the people who have their audio on, we just get to go, mwahaha, we understand. Okay, so we're going to get our list. Oh, yippee skippy, why are we so happy? Because look, 256 is on our list. The square root of 256 is a clean cut 16. That's so exciting. So this just becomes 16. It's not like you have to do any of that division stuff because it was perfect. I honestly made my kids last year, I made them write the word perfect because then they remember if they wrote the word perfect, then they didn't need a square root with it. Ooh, let's write all our y's out. 1, 2, 3, 4, 5, 6. Do you guys remember in kindergarten when all you were doing was actually counting? Yeah, those days are gone. Sorry, coffee break. All right, let's circle our groups of 2. 1, 2, 3. Do you see how we have 3 groups of 2? Look at this. There's my 3 groups of 2. How many are left over? So I'm like, I wonder what goes inside my square root. Nothing, because you didn't have any y's left over, and 256 was perfect. So no need to have a square root. All right, number 12. These are exciting times. You have to do the negative 6 times the 2. Well, the negative 6 times 2 is a negative 12. Now the inside stuff, and we learned this from the last video. Now the inside stuff. So 15 times 75. Okay, so I did 15 there. 15 times 75. That's where I'm getting the 1,125. To me, that sounds like maybe it's a perfect square. We're going to try it. We're going to take the square root of it. I feel like it's a perfect square. I feel like I could be wrong. Okay, my husband's nodding his head yes, like I am wrong. What? I think I am wrong. Okay, then how many s's do we have? Well, I have an s to the third here and nothing over here. So just s to the third. All right, let's work this thing through. So here's my negative 12. And remember I was like, I think it might be perfect. I think I'm wrong. Oh, that stinks. I was really hoping it was perfect, but it's not. But that means that we get to have some fun on the side here. Let's figure out what goes into that number. I know you're dying to know, as I am. Okay, so it was 1125, right guys? 1125 divided by 900. No. 1125 divided by 841. No. Divided by 784. No. You know what? I want you all to know it's not going to divide by an even number because it's an odd number. So I'm just going to work on the odd numbers, okay? Ooh, 625. Come on, 625. Oh, 529. Oh. I'm just using the odd numbers. An odd number will not divide by an even number with like a whole. So that's why I'm doing the odds. Like all those like little rules come into play. If you can remember those little things, it can save a lot of time. This is it. This is gonna be it. Yay! It's 225 and 5. If you're wondering if I'm really excited about that, I really am because math just excites me. Okay, so this is really 225 times 5, like that. And the square root of 225, my paper says, dun, 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 is 15 square roots of 5. Okay, so I'm going to draw a parenthesis. I'm going to do a 15. I'm going to leave a space. Square root of 5. Some of you are thinking, my goodness, she's a lot to take. Yes, I am. Coffee break. Okay, S, 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 because there's 3 of them. There's one group of 2. There it is. Here's one left over. There it is. And now negative 12 times 15. Let's use our handy dandy. Negative 180. Bring down that S to the first power because we have one group of 2. And the trapped 5S. Dun, 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 dun. 3 more. I have kids. Okay, 3 more. I'm surprised you guys haven't heard them this particular video. Okay, so well, one of them's napping. That helps. Negative 9 times a third. Let's use my handy dandy. If you don't have a handy dandy, go online. There's a whole bunch of free ones. Okay, promise. Or follow those directions to download one. But if you are my class, you were given one, so I don't want to hear it. Next, 2863. Ooh, that's large. That's a big number. 1764. Oh dear. I may have exaggerated that square root again. I tend to exaggerate. Okay, then a squared and a to the first, that's 1, 2, 3 altogether. You guys should watch this with your parents. See if you can teach them some algebra. If you can teach somebody something, that means you really know what you're doing. All right, so I'm going to just pray that 1764 is a perfect square root. Let's check. Come on, perfect square root. Oh my goodness, it was like magic. It was so exciting. Thumbs up. Okay, that looks funny. Okay. So yay! Oh my gosh, guys, that was so exciting. And I know you're thinking the same thing. Bring down your negative 3. I'm going to bring down parentheses too. The square root is a perfect 42. Yay! So I don't need to like do that whole thing on the side when it's perfect. It just becomes a perfect 42. No leftovers. Oh, but those A's. I have 3 of them. There's my one group of 2. Boom, boom, boom. See that? One group of 2. That's what that stands for. One group of 2 from the beginning inside. I can pull out one group. And bummer. We do have a leftover A inside. See this leftover guy? He's like, oh, I'm trapped inside. But we don't have any numbers left over. Final answer, negative 3 times 42. Outside times outside, as we indicated in the last video. Boom, boom, boom. And you do not need that A to the first power. I just put it there for emphasis. That is so exciting. I know you think so too. Next. Okay, outside times outside. So 10 times 2. 10 times 2 is 20. Square root of 12 times 6, inside with inside. 72. And then x3 with x3 makes x to the 6th. So you multiply outside with outside, inside with inside. Outside with outside, inside with inside. Did you get that? Outside with outside, inside with inside? Good, me too. Then you drag down the 20. Wow. See how look, he even changed to a curly Q too. Now let's check 72. Maybe we'll get lucky. We're not going to, Casey. That's not nice. Icky, icky. So let's work 72 out on the side with our fancy dancy number. Oh, hold on. Okay. I'll deal with the x's in a second. 72. I wonder what goes into 72. Da, 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 da. Let's try. 72 divided by 81. 72 divided by 64. 72 divided by 49. 72 divided by 36. Ding, 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 ding. It's 36 and 2. So you just keep trying until you get there. So it's 36 times 2. The square root of 36 is 6. The square root of 2 is leftovers. So I'm going to draw parentheses. Uh-oh, my pen's running out of lead. The 6 square root of 2 goes inside. I spaced them out just because I might need some leftovers for my x's. How many x's do I have right here? Ooh, 6 of them. 1, 2, 3, 4, 5, 6. Circle groups of 2. 1, 2, 3. 3 groups of 2. So here are my 3 groups of 2. And there were no leftovers, no lonely x's. Okay, so you do 20 times 6 is 120. X to the third, and then the square root of 2. Ta-da! The x to the third pops down, so is the square root of 2. Last one! I know you guys are so stoked for the last one. Okay, you do negative 1/3 times negative 6. So, yeah, I can write that down, but because we don't have a ton of room, I'm not going to, but I'm going to type into my calculator for those of you who are not listening. I have no idea where I'm going to get positive 2 from. But you're all listening wonderfully with a pair of headphones because that's what you should be doing. Or just with audio on. And parents right now, if you hear me, yes, I am this odd. I think it makes it more interesting. Okay, then you're going to do 18 times 8 because inside with inside. So I get 144. 144 should be one of those things you're like, yes, because it's one of those perfect numbers on your list. And then C5 and C9, well, 5 plus 9, don't multiply the exponents, add the exponents, C14. And I don't need to do that thing on the side for 144. You know why? Look, it's on the list. That's so exciting. The square root of 144 is 12. It's perfect. Now, the reason I had my kids, you don't have to, I just suggest that you write the word perfect. The reason, remember, I had them write the word perfect is so they remember it didn't have a square root you needed to use. So this is just 2 times 12. Now let's work these C's out. Oh dear heavens, there's 14 of them. That's going to require me to work on the side like this. 14 C's. Are you ready? Unless you know how to 14 divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Circle groups of 2. Count your circles. 1, 2, 3, 4, 5, 6, 7. Or just divide by 2. 14 divided by 2. We knew it was going to be 7. So that's C to the 7th power. But the question is, what's inside? Well, there was nothing left over from the 144. Are there any C's left over? No, there are not. So you don't need a square root for this one. Final answer, 2 times 12 is 24. C to the 7th. That is the end of this wonderful video. Oh, my daughter's here. Lily, come tell the students goodbye. They're not. They're just, I'm recording.
Bye.
Here, right here on my headphone.
Bye.
Here, wave to them right on the camera. Ah, bye. High five.
Ow.
Sorry. Love you.
Love you. Now let's watch it.
Oh, I can't wait.